Welcome to an introduction to the PowerShell language Module 3, which is focusing on looping, which is just iterations over code. My name is Brian Kafke with BPC Global Solutions. A little about myself. I'm an advanced data solutions consultant and trainer with BPC Global Solutions. Also a Microsoft MVP. Last year I was a data center cloud MVP, and this year I'm a data platform MVP. I have decades of IT experience focused on data solutions in many different industries. I'm also the author of Pro PowerShell for database developers, published by Apress and available also on Amazon. And I'm a SQL Pass chapter lead. I lead the Rhode Island Microsoft Business Intelligence User Group, and I lead the Southern New England User R Group. And I always get into technical user groups, especially the Microsoft community is very active, very vibrant, and SQL Pass is an international organization that deals with user community support and training related to the SQL Server stack. My contact information is on the right. You can follow me on Twitter at Brian Kafke. Please follow me on YouTube. It's always good to get more followers, and I'm doing more and more training, video classes, etc. for free. And my email address, if you have questions or whatever, you can get my email address right there. So the presentation goals are going to be focused completely on the iterations called loops. We'll talk about what loops are and why we need them, what the types of loops are that are supported by PowerShell, and how do we code these loops? How do we actually write our own loops? And then we'll look a little bit more closely at each type and when should we be using each type of loop. And I'll then get a little more complex and do like one sort of more real-world example of how we use looping constructs. Now at the bottom of the slide, I do have a link on GitHub. So if you go to https://github.com/bkafke/shared/tree/master/PowerShell/YouTube module 3 looping. You can get, it's only one script really, but it has all the different types of looping examples I'm going to go over. So what is a loop? Really, a loop is just there to repeat the execution of one or more lines of code. For example, we might have, say, 2 lines, for example, because usually you want to do it for more than 1 line, but say we have 2 or 3 lines of code and one prints some, the name, and something else prints a title, and we like to do it 20 times. Well, we could copy the lines of code 20 times, but it creates a lot of excessive code, and if you think about it, if anything were to change, we'd have to change all these 20 times 2, whatever, 40 lines of code. So not the most ideal solution. Instead, we can just write, say, 2 lines of code once, and then just loop around or iterate the printing of those lines. So the idea behind a loop is that we want to repeat the execution of one or more lines of code, usually more than one, but it can be one. And the idea is saving us the work and maintenance of multiple lines of code. So it's reuse of code at its most basic level. Now usually we exit the loop based on some conditions, so we may want to do it 5 times. So once we've completed 5 iterations, we want to exit the loop. It could be when we reach a condition like the end of a file or whatever it is. So various types of conditions can result in the ending of a loop, but there should always be some sort of exit condition. And to kind of get your head around it from a non-coding sort of example, imagine you keep throwing a basketball and you just want to sink a shot. Maybe you're playing a game where once you sink a shot, somebody else gets a turn. Well, you're really iterating on a behavior, right? You're going to keep bouncing the ball, throw it at the hoop, it bounces off, you miss. If you're me, you'll try this many times. And then eventually you get lucky, if you're me, and you sink it. And once you sink it, you're good to go. You say, okay, I'm done. And somebody else will come up and take a turn. So that idea of repeating, you keep repeating, is the same idea as a loop. You're doing an activity over and over, and you're repeating until you reach some condition, in this case, when I sink a shot. You can also kind of get a visual impression. Think of a rotary. You come to a road, and you do a rotary, and you can keep going around and around in that rotary as long as you want, but eventually you exit and continue. And the graphic on the right kind of gives a good example. The plane is doing a loop, and in theory it could keep looping and looping and looping, and let's say the pilot decides he wants to loop 5 times. Well, then he would enter the loop, he would go 1, 2, 3, 4, 5, and then exit the loop. So that's the idea of what we do with looping, and we need it again to really reuse code. We don't want to keep typing the same line of code over for this. The types of loops supported by PowerShell include the ones on this slide. The first one is a for loop, which executes pretty much for a fixed number of times based on some variables, but it's an iterative loop that based on a counter. And a for each loop uses iteration, but it does it over a collection of objects, and we'll look at that. The for each object actually processes in PowerShell the pipeline. So you have the result of a commandlet, and you push it into a for each object, and that will iterate over that pipeline. So it's a quasi loop. It's an implicit loop. It's not something you actually have to do a lot of coding for. Now, a very common loop is the while loop. It's going to keep repeating a block of code while some condition is true. And kind of two spin-offs of that are do loops, which is one is do while and do until. Now, the interesting thing about those is these are the only two loops that do the condition testing after it's done an execution, meaning you'll always have at least one execution. Whereas in a while loop, if the condition is false at the beginning, it will not even iterate once. So that's one difference. And finally, we'll look at piping, which is kind of an implicit looping. All right, so let's take a look at an actual example. And I'm in the PowerShell ISE. I'm going to clear this out. Let's clear the console. And I've done other presentations, so if you need an introduction to PowerShell CLI and ISE, please see my other videos. The first one, introducing PowerShell Module 1, didn't really stop putting on the slides the numbering, but I figured this will start making it easier for people. But the first one is on the PowerShell CLI and the ISE, and that gives you a nice general intro to PowerShell. The other one covers the integrated script editor also. And then the second video I did talks about the overall PowerShell language. So I recommend you look at those two first. And this video is really meant to kind of get into specific topics now. My idea is to kind of focus on different areas in PowerShell, and looping is a big construct in any programming language, so that's what we're doing here. All right, so in this example, I'm going to be doing a for loop. And I'll run the loop, and then we can look at how it's constructed. So I'm just going to run this. And the output is right here. Okay, so we've got 5 lines of code really, and each time we've got 0, 1, 2, 3, 4, and it keeps saying the current iteration. So what we've done is we've repeated this line of code 5 times because it started 0. And how do we do it? How do we cause it to do that? Well, let's look at the construction. So the for statement, and this is not a commandlet, it's a statement. So the for statement is using this sort of set of parameters to define how the loop should be controlled. And the first thing that happens is we create a variable automatically with the I, so the variable is called $i. We could have called it anything we want, $Brian, $test, whatever we want. We'll call it $i, and we're setting it equal to 0. Now this will only execute at the very beginning of the loop. So the first time the loop executes, it will initialize I to 0 and create that variable. Now it's going to perform the loop as long as the value of I is less than, that's what the -lt means, is less than 5. And finally, it's every time it iterates, it's going to increment by 1. And that's what plus plus does. So when we say $i plus plus, it says just add 1. We could initialize the I to any value we want. So we could say I is equal to 10 if we wanted. And we could increment also. We could say I plus equal 5, and that means it would increment by 5. But we're doing a pretty standard just one-time increment. We're starting at 0, increment by 1, and we really just want to keep iterating until as long as I is less than 5. So we're going to be doing 0, 1, 2, 3, 4, and we can see that's actually what we got here down below. So it worked exactly what we wanted. Now when you do this type of iteration, it's one of the oldest loops. It's the first loop I ever learned in programming. I learned it in the basic language many years ago. It's called a for next loop in BASIC, but it's the same type of thing. It exists in C, it exists in C++, it's in Java, it's in C#, this type of thing. And the thing about it is it's very simple, it's very easy to use. It's ideally suited when you really just want to kind of do a loop of code for a relatively fixed number of times. So you can set it, iterate, and the nice thing about it, notice, is it takes care of incrementing automatically. It's part of the definition of the loop. So we'll see other loops where it doesn't do that. So it's a nice clean loop. It takes care of sort of the dirty work for us. Once we set up that header from here to here, we don't really have to think much about the loop anymore. But it's not as flexible. The only thing we can really do with this type of loop is count and compare our value to some sort of count. Compare that to the for each loop, and again, this is a statement, not a commandlet. What the for each does is it's designed to loop over a collection or an array. Let me clear out again. And what I'm doing here is I'm setting $array, it's just the name of my array, and I'm putting these names in it, these strings. And I can display what's in there just by highlighting and running the little page run. We can see there Brian, Joe, Steve, Sue, Mary. So it's a list of items. So it's a collection. What we want to do is we want to basically loop over that list or iterate over it and do something with each element. And the way we can do that is by saying for each item in array. Now array is the list we're going to work, the collection we want to iterate over. But where did $item come from? Well, it actually didn't come from anywhere. What we're telling PowerShell to do is create a new variable called item. We could have called this X. We could have called it anything we want. But we decided to call item because it's one item in an array. And we're saying for each item in array, do this line of code. So what we're really doing is saying every time you iterate, including the first time, go to the first element of the array and load it into $item. And then do my code, and now I have this variable which I can access. So let's see what this looks like. Just going to run that code and see how it says the current name is Brian, the current name is Joe, Steve, Sue, Mary. So it just looped over each name and then printed the name. And I embedded the $item in the string because that will automatically get expanded to its value. And we can see a few nice things about this is it's iterating over collection. We're not counting. We don't need to worry about when it should stop really because we want it to loop over the entire array. So it takes care of that for us. So one of the nice features of a for each loop is it automatically takes care of beginning and ending and when to stop, and the end condition is when it reaches the end of the loop. That's implicit in the for each. So it's ideal, I guess, for processing when we have that type of situation. Now, similar to for each, I want to highlight something different is the for each object. Now, in the for each, we have an array defined as a variable. But what if we just want to take something like getChildItem and watch what happens? So getChildItem down below is just a list of files in my folder in the default location, and I'm piping that list, the result of that commandlet, into for each object. So for each object is designed not to take an array directly, but to take the pipeline. And so that's what's happening here. And then it's going to process that pipeline. It's going to run this block of code for every row in the pipeline. Okay, so I'm going to say it again. It's going to do the for each object. It's going to iterate over our block of code for every row in the pipeline. And as it does so, it's going to put the row, each row of the pipeline, into $_. So $_ will contain whatever the current row is in the processing of the pipeline. So we'll start with first row, second row, third row, and it's iterating over. So let's see what happens when we run this. I'm going to clear this out just to make our code easy to see. We can see it's just listing each file and then giving the name, the full path. That's what's going on. So again, the for each is very similar to for each object, but one is designed, the for each is designed to work with an actual variable that holds the collection, whereas the for each object is designed to receive the pipeline. And notice we didn't have to give it a name of an object. We don't give it the name of the array, and we don't tell it what to call each row. We let PowerShell just use $_. It's implicit naming, and we're good to go. We can use that. Now, since if we look at getChildItem, it gives us many different properties. So we can access an individual property by using the period full name, which is the name of the file, the full path. And so that gives us that. But we could have used other properties, the size, the date, etc. So that's a way we can extract just a piece that we want. One other thing I want to point out is why these parentheses? Why couldn't we just do this without the parentheses? And the answer is I'm basically doing, I'm sticking two things together. The file name is as a string, and then I'm adding in the $_ period file name, full name. And notice that the quotes end. The file name is : space is in double quotes. So I'm adding the other part as two separate pieces. to force PowerShell to do both of those and return a single string which can be written to the host, the write host commandlet, I need to put around parentheses, so we'll do that first. If I don't, PowerShell is going to get confused and we'll try to do write host, file name string, and it doesn't know what to do with the other piece. Like, it doesn't take 2 parameters, why you give me 2. So that parentheses forces the order of execution and makes it work. All right, so now let's look at another loop. This is called the while loop. I'm going to clear down below. And I'll run it and then we can talk about what it does. So I'm just going to run this block. And it just looped 5 times, similar to the original for loop we did. Now the while loop is very popular. It's probably the most common loop you'll ever see in programming because it's very easy to read and it fits most looping requirements in that it's adaptable. We can say while, and our condition here can be anything we want it to be. It could be while a string is equal to some value. It can be while one number is less than 5 and another number is greater than 5 and something else is in something else. A lot of flexibility here. So again, it's popular. And notice it doesn't implicitly create our variable x. We have to create that and initialize it ourselves. We want to initialize it because PowerShell remembers the value. And if we didn't, if we were to rerun the script, it will not run the second time because x already has a value of 5 when it hit the limit. So we can see that it worked. And the idea of the while loop is it's just going to run this block of code while this is true. And again, the while is a statement, not a commandlet. And notice we also have to do the incrementing ourselves, x++. So here's the odd thing about this particular block of code. This is a bad example of how to use a while loop, but it's simple and one of the reasons I want to convey it. And the reason I say that is because although it works, if we look at this for loop, it's doing the same thing that this loop did. And the for loop automatically takes care of work for us and eliminates the risk of introducing a bug into our code. So while we can do a while loop like this, I would favor, if this is really what you're trying to do, something where it's counting and then when you're done you want to get out, I would favor the for loop. The while loop is better for something like if you're waiting maybe for a string to equal a certain value, if you're looking for somebody to input a value, we'll see that later, and then react to that. So the while loop is nice for its flexibility in input values, but if you need incrementers, initialize variables and things, it may not be the best loop to use. But again, it's very popular. And one of the things that's nice is it will execute this test before it runs the loop. So, and I'm going to show you this. So I'm saying while it's less than 5. Suppose I type a value 15. Now watch this closely. If I run that, notice it didn't run even once. It never did that write statement. And that's because the condition is false right out of the gate. And if it's false out of the gate, it doesn't even iterate once. That's important to realize because not all loops work like that, as we are going to see. So now we're going to hit the do loops. There's a do while and a do until. The do loop is interesting in that it says do, okay, and then the block of code, similar to the while, but the condition, the while statement, is after the do loop. And that's an interesting thing because what it actually does is it always iterates, it will always execute at least once, unlike what we just saw with the while, regardless of the condition. And I'll prove that to you here because I'll make this 22 and I'll just run this block of code and the condition is while it's less than 5 and it's still incremented and output a value. So it's kind of strange. Useful if you need at least one execution and only after that do you want to consider the terminating condition, which is what this is. So this block will run as long as the $val is less than 5. And as we saw, it will iterate at least once, no matter what, because it's executing the condition after the fact. So we'll run this and see what it does. And we get all the way through here, 1, 2, 3, 4, 5. And it's a little bit different. We're incrementing at the very beginning, so by the time it gets through here, it does it. First time it starts off, it's actually going to be 1 when it hits this, and it iterates through until as long as it's less than 5. All right, now similar to this, this is using as long as this condition is true. So this is while. The until does just the opposite of the while. It says do this until a condition is true. So this is saying you can do this as long as value is less than 5, but here I'm saying do this until the value is greater than 5. So it's kind of the opposite way of approaching it. And I'm going to clear this out. Okay, and let me get rid of the 20 here and set it to 0. And you get this iteration. And that's because it's only when it hits the value of 6 is it greater than 5. But notice, because of its post-evaluation, it's actually going to execute what appears to be one extra time. All right, so be careful with the do untils. I would say there's very specific circumstances where these are probably the best ones to use. But when you're thinking of a do while or do until, you're probably going to be better off using the good old while loop. Now, technically speaking, the pipeline is not a formal loop because you don't have to create any looping construct. But when I say get process, like this, I'm getting all this information. This is basically all the processes running on my machine. And I'm going to pipe it into another commandlet, select object. And then I'm going to pick off, the select object lets me pick the properties I want. And it worked very nicely. The point of including this is I can even filter and I can do a lot of things. Do not use loops unless you need them. That's really the point I wanted to make here. Piping can do a lot of the same things that a looping construct can do, and it avoids not only the extra work of coding the loop, but the potential bugs that those loops could introduce. You may forget to initialize a variable. You may forget to set the condition to what it needs to be. All right. Finally, what I want to show you is a practice in loops that you can do, but be very careful about this. And I'm covering it almost really reluctantly because I don't really want to encourage this type of practice. But I'm a believer that you need to be able to do anything in a program that suits your needs and requirements, as long as you are sort of aware of the risks it involves. So using things when it makes sense. The problem is, if you're not a experienced programmer, you can get yourself into trouble with some of these things. And one of them is breaking out of a loop early and violating the terminating condition. So let me look at, I'll show you what I mean. So we're going to do similar to our do until loop or do while loop before. And the only difference is we're going to do a little evaluation here that it's going to check and say if $val is equal to 8, prints this message and then executes the statement break. What does break do? Break exits the loop. It acts as if the terminating condition is true, but it's not. So in this case, what break is going to do is exit the loop, but val will not be incremented. And for that reason, later on, you might get into issues where you're expecting a value to be something else, or you're wondering, why didn't it iterate all the way through? I think in simple examples like this, it's not that big a deal. But if you're doing, imagine you have 20 pages of code in this loop. It could be very difficult if you've got a lot of places with breaks in them. You're like, where is it exiting? Why is it exiting? So that's why it's something I would discourage. But there may be times when it fits the need and you're aware of it, you document it, but lots of comments around it or whatever, and it makes sense to do that. So let me just kind of demo this code. Just going to run it. And we can see that it did that. It went right through 1 through 8 and then said interrupting loop. So this block stopped the code when, if I didn't have it, it would have gone all the way through to basically until 10. Until it hit 10, then it was terminated. All right, so the key thing there is the break will get you out. And another reason for covering that is you may see it in code examples that you see out there. So let's go back to our little slide presentation, and I want to talk about a few other things. I'm going to review these loops again, and I like the slides because I can highlight things in case anything was missed. So we covered the for loop, and notice that when we do the for loop, the overall pattern to this that this loop works with is the first thing we specify is a variable name that's going to be used to control the loop iterations, and we initialize it to some value. That's the first thing. Then a semicolon. Then we specify the condition under which this loop will execute. If that condition is not true, it will not execute the loop. And finally, we define the incrementer. We say, how are we going to increment this variable? And plus plus just does it by 1, which is fine. But we could say plus equal 5, plus equal 6. This is all based on integers. We're incrementing, we're running a number of times and using a number to control it. And then it just runs it. And we can use the $i in our loop. So when you have a number somewhere, like maybe you have a count of how many, you have so many of something, you could use that in a situation like this. When you know what you're trying to, basically how many iterations you need. It's ideally suited for when you know you need a fixed number, like I want to iterate 20 times or 30 times. That's a perfect scenario, which might be the case if you want to just say, for instance, list the first 10 lines in a file. A for loop would be great. You could just do that. And by the way, there's a commandlet you can use to do that. You don't need to do this, but if you wanted to, you could do that for 10 times, read the line, and dump it out. For each loop, as we talked about, is designed to work over a collection. And we saw here this collection or array, and a collection is just an array of objects. So we have here array, and we've got Brian, Joe, Stephen. We did this, and then we iterate over that. So a collection is really well suited to just the situation where you have a variable that holds a collection, and you want to loop over it. Perfect. And an implicit loop, we saw the for each object loop. And when you do the for each object loop, you're pushing the pipeline. You're really using the pipeline. So we're doing get child item. And then we use the pipeline, which is that bar, which pushes it into the for each object. And then we have a block of code that will iterate over it. Remember, the $_ holds each row as it passes through the pipeline. And notice the begin and end code blocks. Now this one I formatted across. It was easier to do it that way, but so I wanted to mark those off. And this is ideally used when you want to leverage the pipeline and you don't want to have to build an actual loop. The while loop is to iterate something while some condition is true, and it's a simple loop to set up. And the example here is probably better suited, as I mentioned, to a for loop. But the idea is you're going to do some block of code while something is true, and you just keep iterating over it. It's a nice general loop, and the nice thing is the flexibility of the terminating condition, because you can pretty much put any expression that can resolve to true or false in there. We talked about the do while loop, and it's very similar to the while loop, except it's going to do the block of code, and then the while condition is expressed after the block of code, so it always executes at least once. And we also, as with the other example, because we're using numbers, we have to initialize a variable first and then use it for iteration. If we're going to use numbers to evaluate it, we could, like the while loop, it could have nothing to do with numbers. It could be something like while end of file is not true, or while answer is not yes, or something. So I'm using, it's not the best example. It's simple, and I also wanted to contrast it where the for loop would be probably a better loop in this type of a situation. Now the do until will execute the block of code until a condition is true. So it's watching for the false condition. When I will stop when this is true. It's looking for when that happens. So it's just going to keep looping until some condition. And again, it's going to always iterate once because that's where it starts. And this is where we didn't do any kind of special loop at all. We just used the piping itself. And the point of this was that the piping operator, and just using piping, can eliminate the need for a loop altogether. PowerShell is great that it has that, so I recommend using the fact that it can pipe. I personally, if I can avoid a loop and do something with piping, I always try to do that because it's just more efficient, it's faster, and it reduces the code you need to maintain and decreases bugs. And the other thing we did talk about was the break statement. And the break statement is the idea where you're exiting the loop prematurely. And we see here that we went over this. The if statement is now looking for a condition that's going to happen before the loop is finished running, and then it uses the break to get out of the loop. Again, you want to try to avoid using breaks, but there may be situations in which you want to do that. So I wanted to do one last kind of demo here because I think these are very simple cases, and I wanted to show you something a little more advanced. So let me just run through this block of code, and then I'll kind of step through it. So it's like a little number guessing game. So I'm going to run it. And notice down below in the console, it's now prompting me enter a guess, and it's a number from 1 to 100. I'll explain that in a minute. So I'll guess 88. And it says wrong number, so it says, do you want to try again? I say yes. I'll say 77. Wrong number. Do you want to try again? I'll say no. And it exited my loop. It stopped asking me for things. It ended. So let's look at how this is written. First thing I did here, this is not really part of looping, but I want to just kind of make an example of a short application. I'm going to get a random number. I'm going to store my random number in random number. That's just my name. I'm going to use the get random commandlet. And the minimum one maximum establishes the range that the number should be between. And I'm creating a variable and initializing it. Keep trying, $ keep trying. I set it equal to y. And then I define my block. It's a while block or while loop. And I say while keep trying, to upper is equal to uppercase y. So basically what I'm saying is, as long as keep trying is yes or y, then it's going to keep doing the loop. Now I like to put this in. It's not really necessary in PowerShell. PowerShell is not case sensitive, but there are ways to, on the conditions under which it can be case sensitive. So I like to do this to upper, because what that means is it's going to convert. If I were to enter lowercase y, it will convert to uppercase y, and I'm guaranteed it will always match even if I were to enter lowercase, which if you remember I did right here. All right, so condition, so I'm going to do that. And what I do then is I say $guess variable is going to use read host, enter your guess. So this part's is where it asks you for a number to guess between. And then I say if guess dash equal is equal to the random number I generated, then I'm going to say you win. I've yet to win this game, so apparently I'm not good at guessing numbers. But otherwise, which is what we did see in my code, it says, sorry, that's the wrong number. And then it says, keep trying, and asks you, do you want to try again? And I entered yes the first time, right? I can see it here. And it asked me, and I entered another guess. And again, sorry, and then I said no, and it exited. So when I said no, the value of keep trying became n, and it jumped from the end of the loop up to the while statement again. It evaluated, is keep trying dot to upper equal to y? And it's not. It was an n, so it exited the loop. So I like that a little better. I wanted to walk through because it's explaining how the application works, this little game, number guessing. But that's the kind of thing you would do. There are times when you're going to prompt somebody, are you done? Do you want to exit a game? Do you want to do something? You could have a loop that's very large. It could span pages of code. It can be many different conditions. It could be when a file reaches the end. It could be if you go to open a table in SQL Server and the table's not there and you want to do something, any kind of conditions. So I just wanted to give a real world, somewhat real world at least, example. Not sure how many of us are out there writing word guessing games or number guessing games. So a couple of cautions on looping. They can be a source of bugs, which is why I try to use other methods when I can. It's nothing wrong with loops. They're awesome. They're great. But they can introduce bugs if you're not careful with them. To avoid some of the issues, first make sure if you're using whatever variables you have, and remember the for loop is nice because it initializes and takes care of initializing variables. But if you're using other variables and it's not part of initializing in the loop by itself, like in a for loop, make sure you initialize the variable before you use it. Also, this is where people get into the most trouble. It's called an infinite loop. An infinite loop happens when the terminating condition in a loop is never reached. In other words, you're saying when x equals 100, but you never increment x. Therefore, x never equals 100, and it will run forever. So you want to make sure when you're writing any kind of code with the loop that the exit condition will always be reached somehow. And as I talked about through this, match the loop to the type of need you have. If you know you need to just loop 10 times, then the for loop is the way to go. If you need to loop over a collection, then use the for each. If you want to use the pipeline, you can use it directly, or you can use the for each object. And then the while loop is a general good catch-all when you have some other condition that is not numeric. Maybe it's like end of file condition, or when somebody enters a value, as we saw in the game. That's a good example where the while loop works. And there is do until and do while, and I would generally say don't use those unless there's some specific reason you need them, but be aware how they work. The other thing you can do is you can input one loop inside another loop, and I recommend trying to avoid that as much as possible. There are times, again, where you might need to do it, but just be very careful and make sure you separate your variables and variable names very carefully when you're doing that in terms of the looping control, because one loop can get confused with another loop and it can get you into some trouble. Again, at the bottom of the page, while I'm talking, write that down if you like, but I am on GitHub with the script available that I just walked through. What we just talked about, we talked about what loops are, why we need them, and the idea again is we have some number of lines of code that we'd like to repeat in execution. We looked at the different types of loops. We saw the for loop and the for each loop. We looked at piping for each object. sort of really a piping kind of thing. We looked at the while loop. We looked at the do until and do while. So we saw a lot of different ones, and we looked at how to control the loops. They always have a looping construct, and there's always some sort of a terminating condition, at least in PowerShell's loops. So there's a sort of fixed thing we're looking at to end the condition. And we looked at those each type, when to use it. And then I finally walked through a sort of real world case of, granted, not too real world, but with the number guessing, a little more sophistication to it on when you would use, for instance, a while loop. And I gave you some cautions or recommendations. Looping is part of programming. It's what we do. And it really leverages code itself, because the whole idea of code is repetition. We do something over and over. Why not let a computer program do it? If we want to send out 3,000 letters, it's a lot easier to let a program loop over all of the recipients and send out letters than it is for us to sit there and manually do that. So we need to use them, but we need to think about what we're doing in our code. And I hope you found this presentation useful. And as I mentioned, subscribe. There'll be more things to come, but I think we did a pretty good job here, I hope, covering looping constructs in PowerShell. Thank you.
Hi, I'm Brian Kafke. I'm the voice behind the videos. I hope you've enjoyed them. Hope you consider subscribing. My plans are to do more educational videos and things related to the IT world, in particular on the data platform. So I want to keep going with the PowerShell training, but I also do a lot with R, do some things lately with Python, and a lot of things with the Microsoft SQL Server stack. Also quite well versed in Oracle and PostgreSQL. So a lot of different areas I'll probably look at over time. And I hope you're enjoying this. And if you have any comments or things you'd like to see covered, please let me know. Thank you.